excited to turn it over to our speaker today. James Cao is the CEO at Ironwood Cyber, and he's going to talk to us about the Agent Identity Protocol, which is a new kind of open source initiative to try and tackle auth and identity on agents and MCPs. And I'm super excited for this talk. It's a standard that came out of the kind of community collaboration, and James has been one of the key people driving it. So we're really lucky to have him on the talk today. So James, thank you so much for joining us.
Thank you, Shannon, for having me.
Absolutely. I've got your slides up, so why don't you take it away?
Awesome. Well, nice to meet you, everyone. My name is James Cao. I became CEO of Ironwood Cyber last year, which is a cybersecurity firm based in Texas. And I also founded Moncao, which is a engineering consultation firm. But today I want to present the Agent Identity Protocol as one of the primary maintainers for this project. I'm a huge believer in open source technology. I believe it drives innovation and progress. It's the backbone for the internet, and excited to work with the community and hopefully meet other interested engineers or collaborators who can poke holes in this project and help build it out so that we can have secure systems. Also, I want to shout out to Carlos Gutierrez, who's a senior engineer at NVIDIA. He was the initial cornerstone for the start of this project, and the person who was supposed to speak, and now I'm just filling in for him. So to get into it, we'll go into the agenda of what the problem is, why this is being built out, what AIP is, and the technical details around the standards that we're building, as well as we'll do a demo at the end. So I won't dive too deep in the charts. I know, working in tech, we want to dive straight to the source. So I'll try and run through this as quickly and efficiently as possible. So where did this all start? Well, it kind of started from the problem of MCP servers, or mainly more agentic AI, having God mode for most things or everything. When you have agents running your system, they're running as you. They have access to, your user permissions, any API keys and secrets that you give it access to. And I remember when OpenClaw was coming out, people were freaking out. They were like, "No, this is so cool. This is amazing." And a lot of people in the security space, rightly so, were like, "You're just gonna let this tool run your life?" And a lot of people did. And I remember there was a video or a post about an engineer who, told OpenClaw to manage their emails and start deleting things. So from that space, we can see that security is a really big issue, and we want to figure out a way to solve it, right? There's no distinction between the human and the agent, and the agent can call any tool that it wishes per discretion, per the task that is given. The attack surface that we see is, you have an agent, it goes out and does something, it gets a poison document, it ingests the data with some, and then indirect prompt injection happens, and a tool is hijacked to do something malicious. We have Gemini Jack, which is an example of exfiltration of data, and it's something that I'm actually working with some researchers in Singapore. They created a paper, if anybody's interested, called bypassing indirect prompt injection through something with breaking out, the the attack surface, and then how they retrieve like the actual data. So we believe that any data that's out on the internet or that's being ingested by the agent is a potential attack surface that you call it to do something. Next thing you know, the data is exfiltrating data and then completing the task, and you never know what happens. This leads us to AIP. So AIP is essentially an open source standard for authentication, attestation, authorization, and governance of AI agents. The thing about AIP is we're building everything out with the schema and keeping everything very agnostic so that it can be implemented by anybody in any language. The reason why I'm highlighting the authorization component is because the authentication, the attestation is actually subject to change right now. I'm actually working with some people in the IETF working group. For those who are not familiar with the IETF is the Internet Engineering Task Force. They create standards like TCP over IP. And this week, actually, they're in Shenzhen for IETF 125. And a lot of what they're talking about is talking about agentic authentication and authorization. So we're talking with them and saying like, hey, like how can we, understand where the market is moving for agents, and how can we handle parts of what we already built out, such as like the authorization component, which I'll go into in the next slides. So AIP is actually built into a two-layer architecture. Layer one, which is like the identity of the agent, and then layer two, which is policy enforcement. So again, the identity portion is very subject to change based on, what the community decides is the best way to identify how an agent is different from a human. But at a core level, we want to keep it very flexible and say that there is, a root registry that signs, serves for agents, and we can attest that this agent is who this agent claims to be, and it can access the tools that, it's authorized to access. The layer two enforcement is a little bit more unique to this project, and it's a transparent proxy that we want to provide as a complementary layer to MCP. So the enforcement layer is something that sits on top of or between the server and the agent to verify that the agent is who it says it is. It can block tool calls. It's policy based, and also provides an audit trail. So any security engineer that goes in and say, okay, this agent that we have running on this enterprise uh, access these tools at this time, and it was blocked here, and it was like allowed here. And again, it's based on the standards of how do we want to see agentic communication play out in the future, so that it can be secure, but also at the same time frictionless, for lack of a better buzzword. The agent attestation token is something that we kind of proposed of, how the agent will look. But as I mentioned earlier, as standards develop among the IETF and among the community, this can be subject to change. But at the core, again, the layer one identity of AIP is based on a claim, whatever the claim may look like, and essentially, who controls this agent, what is this agent allowed to do, and how long is it allowed to do what it's supposed to do to carry out the workload that a human designates to it. Now I'm going to dive into the proxy, the layer two enforcement layer of AIP. So the AIP proxy is essentially a proxy that sits between the client and the tool server. We actually have a Go implementation that's built out, but it can do policies based on which tools can be allowed, denied, or asked. And it tracks every tool that's called by wrapping around the MCP server, um, being called in an agent config. And then as the agent does this thing, if there's any policy, or sorry, any tool that it calls that it's not allowed to call, it'll either block or ask the human. So we want to create something that also includes the human in the loop, so that if there's anything critical, such as deleting emails, right? Let's say I build an agent, like a chatbot, that should only, provide status on my order. I don't want it to ever touch a delete, like a delete. And this is just an extra layers of security. It's not supposed to replace, what already exists, but it's just complementary. And if you want extra security and you want extra, checks, this is what this is built for. There's essentially five enforcement steps for AIP, with the layer one and the layer two, and then how the layer one kind of blends into the layer two. As mentioned earlier, the layer one is the identity of the agent, right? Who is this agent? What is it allowed to do? And what is it allowed to access? Uh, AAT, the AAT signature, the agent attestation token, is the identity of the agent. Essentially, the standards calls to verify this, checks that the token is allowed to do what it's supposed to do, and that is then passed into the layer two portion of AIP. where then we have a policy engine that checks, okay, like this agent is good. Can it run this tool call? Okay, you can run this tool call, run it. There's data loss prevention scans that we have built in into the YAML so that you can check, what data is coming out, just to ensure that no secrets are being leaked, and then also write that out into an audit log as well. Uh, the policy engine was the initial start of this project because, again, we want to start small, not over-engineer everything, but ensure that it can scale out as people use it more. So the project right now is in its very infantile stage. So essentially, it's a policy engine that you run in your local directory and allows you to say like, okay, I want this MCP server that is being wrapped around to only access these tools. And there's actually an implicit deny. So it operates on the concept of least privilege. The agent should never be able to access a tool by design because it is untrusted. So anything that we want to add in is explicitly allowed. And we're also gonna add in rules to say like, okay, like let's say I don't want to block this tool all the time, but I want to ask it uh, so that when it does run, I can, either approve or deny for that specific situation. Again, the policy engine is very basic, and we really welcome any of the community to uh, provide any input and see if there's anything that they believe would be helpful or non-helpful in this spec. The secondary thing as well is the policy engine is something that we want to tie in into the identity portion, where we have, a centralized registry that says this agent can access like XYZ. That way, at the layer two enforcement layer, we don't have to create different YAMLs for different use cases, but you can say like, okay, I can connect to like, let's say an AIP registry server, and based on that connection and like the token that gets out, like this agent is able to only do the responsibilities designated to, this type of chatbot, for example. Tool authorization is very basic. We operate on either allowing the tool, so you say, yeah, you can, the agent can call this whenever it wants to complete its task, and ask. So we say, hey, like, let's see, like every single time this is called, we want to make sure that it should be called in that situation, and we want a human to check. And then, as mentioned earlier, implicit deny. All tools are blocked, if not explicitly allowed. And we want to return these, or we're putting together these standards to also include in, what errors are returned so that when people, if they integrate this into their own systems, then again, regardless of language or, infrastructure, every error code is the same, every success code is the same, and we can build out a community that uses something complementary to agentic security. The DLP scanning is very basic. So essentially, the agent will, and then the proxy, it will just check detection, basic regex, based on the user of anything that like they want to catch as tools are being called. The DLP, I would say, if there's anybody out there who is an expert on data loss prevention, we would love your input on this section to improve it because I think this is something that can be, more robust and added upon, and we always welcome any comments to prevent data exfiltration at a more robust level, especially when more people start to use agents and the technology moves really rapidly. How do we ensure that, instead of just like saying, hey, like everything with these keys or this structure and this pattern is blocked or is caught, how do we be a little bit more dynamic with it? That's something that I don't have an answer to right now, but open to the community to understand more if that's something that can be worked. And the other part is human loop approval. As I mentioned, we want to ensure that a human can um, approve or deny a tool as it comes up because we can catch an agent in real time. If you're running an agent, and the next thing you know, like this agent, like run, all these open claw setups, and this agent all of a sudden wants to start, sending data, or downloading like from websites or things that you don't know, or running Python. I don't know. You can say like, okay, like I didn't explicitly allow this agent to do this. Why is it doing this? Somewhere in like the chain, I need to check. And really critical for things that are a little bit more high risk, like deleting emails. And lastly, an immutable audit trail. Uh, this is something that we want to build in the standard because we want to see what the agent's doing, at a security level. And I think, coming from a security background myself, and loving to use all of the AI agents, it can be a little bit more difficult to say like, okay, like I'm running all these agents, like what is it doing? Like how is it playing in security? Like, where are these tools being called? What is it accessing? So just providing a level of transparency that can give the added was it accreditation or no? I guess auditability of an agent as it does its work. And so we have the full chain from a user does this to the agent has done what it's supposed to do. And yeah, with the AIP proxy, how does it compare to, a standard MCP server? With the proxy, it is hidden and it can block any tool that is not defined in the policy. And essentially just a complementary, catcher for anything that could happen that you don't want to happen in terms of, okay, like I'm running these servers right now. I want to add an extra level of security. Let me just pop this proxy in and then go. Not going to go too deep into this chart, but just how AIP works versus standard MCP, standard authorization processes already there. This is something that's built more for the intent and for the tools that the agents are calling. So mentioned earlier, there's two parts of AIP. There's a layer one, which is the identity that answers who this agent is, and then the enforcement layer, which is the why and what can it do. So AIP is something that combines the two to share that this agent should only be doing what it's supposed to do. And if there's any malicious intended actions that occur out of it, we can check and say, hey, let's stop this at the source, or let's check and see where, at what point in the agent lifecycle did it get compromised. So, as I mentioned, AIP is very, very new. It started maybe a couple months ago, and it's at the current implementation that we have now, we have a localhost proxy written in Go, which allows for basic tool allow, listing, deny listing, validation with the regex of like DLP, OS dialogues, human loop, and like JSON audit logging. One thing that we want to build out with the community is how do we take something that works locally and implement that at scale for enterprises, for teams that are running the like multiple agents. How can we make this useful for the community? And how do we build out a standard that can be easily used by anybody in the community as AI moves so rapidly? And how we build it so that when people see security, they don't see it as a chore that they have to do, but they see it as something that you know, provides them that edge, that competitive advantage, and is easily implementable and easily trusted and easily verified by uh, people who are poking and digging deep into it and deep in the weeds of building out the technology and say like, hey, this is what we need for security and this is what we don't need. So yeah.
Hey James, I just want to be a little mindful of time. I know you
Okay.
want to do a demo as well. We've kind of gone about 20 minutes. Do you want to dive into that demo now? I think you've kind of covered the
Yeah,
concept
yeah.
well. I'd
I,
love to.
I I ju- I just finished, so yeah, apologize for the
No worries,
the
buddy.
over on the chart, but yeah,
Yeah,
let's
I'm
just
excited to see
dive
it.
into the demo.
Yeah, let's
Yeah.
take a look how this actually works.
So for anybody who wants to, jump into the demo, you can go to our GitHub, which is on Open Agent Identity Protocol. And I'm following our tutorial 6, which is external enforcement with our Go proxy. So the proxy is on a different repository, but we can use that to wrap around a basic MCP server that just stores data in memory. Um, so I already set up like my config. So I created my binary in this demo folder, and I created a basic playground policy in my demo folder. So how it works is you can also use you can create a config with cursor natively. So create the policy, create the binary, and then you want to integrate with a tool like cursor. Um, you just run this command to generate the config, and then paste it into your mcp.json. Right now, cursor that I have run up is already wrapped around the server and the proxy. But as you can see, it just is a command with the binary used to target a server, and it will run the server as a subprocess. So let's see, I have two chats up that I ran to test, but we'll see it live right now and see how the policy works. Right now, it's explicitly denying everything. The tool set is a mock email server where I can list this emails of my user, and I can list all emails. Those are the only tools allowed. So let's just test this out. Okay, yo. So I want you to use the AIP Playground tool to list my emails. I am Alice. All right. So cursor finished and it says here are the emails for Alice. Alice from AIP Playground, and it has like an email example 1 from a boss and an email example 2 from like a policy update. So the other tools, I'll see up there, there's a list all emails tool. So I just want to run, all right, now list all emails using this MCP server. So now it's fetching the MCP tool, but the request was blocked because of this explicit denied policy in the agent policy that we created, which we want to enforce, and we only want to allow one tool, which lists my emails. So therefore, this tool can never be called because it was never explicitly allowed. Because of time, I wanted to also show well, the OS dialog one might be a little bit more time consuming to run, but it's the same thing where you create a playground policy and essentially just uncomment this out to say, I want the agent, the proxy to prompt and ask if listing all emails is okay by the agent or if it should deny. And then based on the human input, then it will proceed to call this tool or not. Other than that, the demo again was really basic. This is a project that we're building out right now, and we want to get out, implementations in Rust, Python, all the other languages, and also SDKs that can be built into what people are building out in their own things, so that they can just add in a proxy layer to catch and implement in their own structure. So. Thank you again for the platform and the opportunity to speak, and apologies for going over 20 minutes. I know I promised that I was gonna stay low on the charts, but yeah,
It's just too much
just
content,
ran
man.
over.
You just got like too much to say. Thanks so much,
Yeah,
James. Great having you here and covering all this. There was a couple questions that came in. I mean, one person in the community asked if that they, if you're chatting with a protected bot and you explicitly mention to avoid the policy, will it get bypassed that easily? Like, I assume not, but can you just go around this by telling the LLM not to touch it?
yeah. I mean, like the basis of the policy is it's not ever going to um, it will not protect against any calls that bypass the proxy in terms of the LLM direct to the MCP server. So there has to be a way to enforce that the MCP server that's being called or the toolset that's being called is already wrapped around the proxy. So
So
that's something
basically, you're
that
saying like all traffic has to go through the proxy before it can hit the MCP server, obviously. Otherwise, it can't do the filtering and can't sort
exactly, exactly.
so, like if I'm trying to understand this as sort of an implementation, it's effectively two big pieces. One which is sort of cryptographic identity side, which is all about public-private key signing of MCP agents and their identities. And then there's this whole separate sort of filtering side. What's the relationship between the two? I mean, they feel like kind of two separate protocols or two separate projects. Like, why? I mean, what, like, I could see one thriving and the other not, or vice versa. Like, why do you feel like these are two parts of the same thing? Like, how is this one? Is it just you're like, this is the holistic way to secure agents, is to identify them and then to have policies about what they can do that are independent of the MCP? Is that why you've kind of combined this into one
Yeah.
project, or what?
Yeah, that's a great question. And I think it stems from the authentication component and then the authorization component, right? So we want to authenticate that the agent is who it says it is, but at the same time, we want to authorize that who it says it is allowed to do what it's supposed to do. So we saw it as like the identity portion of the agent, who the agent is, what it's allowed to do, all these things. The authorization, what is authorized to do, such as what tools it's allowed to call, can be baked into that component where the agent itself, because let's say I'm running like OpenClaw out there, right? I can say this agent here is allowed to hit MCP server one. When it hits MCP server one, the other tokens that come from like the third-party registration server can say, okay, now it's authorized because a third party says, I can say that this agent is, you know, good for hitting these tools and is allowed to do all that stuff. So maybe there's a portion that we can break out, but I've always seen authentication, authorization as kind of complementary to each other. And if there's a better way that we can break that out, I'm definitely open to that.
Darren, any questions you want to ask? I have a
I'm
couple more,
trying to
but
figure out how to phrase a question or whatnot, where it's like, do you think this framework would work to secure OpenClaw?
Mm, personally, I think so because let's say you only want OpenClaw to book flights for you, right? And check into your flights. By this standard, any tool that accesses your flight log should only be um, allowed to do those two things, and everything is explicitly denied. It operates on the principle of least privilege. Um, so I think that anything that says, "Hey, you can't do this unless you allow it," is better than saying, "Hey, this is a Wild West. Let it just run and do what it's supposed to do." So I think the answer is yes, but the the additional question is how do we build out what's already kind of being defined from a agentic standard to apply it to what enterprises are doing and how people are actually running um, MCP servers like in the wild, right?
Yeah, I mean, the kind of so when I look, because I think OpenClaws are really interesting, because I've been spending some time with it, just as everyone has. It's like a really interesting thing because it presents so many security problems, but it clearly has such amazing utility. So one of the most interesting challenges is how to properly secure it. And so I look at a framework of kind of what you've done here, and it seems to be counter to the direction of the way AI agents are going. Where like there's this very fine line between, because like we look at like authorization as like API calls, like IAM, things like that. It's concrete, it's discrete, it's parameters, it's structured, it's very structured. But the direction of agents is really unstructured behavior, and so you see that more and more with, like, let's say something like code mode, where you generate code to do things. So it's like the behavior of the agents, like when they start calling these tools, that it's very hard to inspect them from a regex or a field or a tool, because they're very kind of like opaque in nature. But like when I look at like authorization, it's like you can say like attack vectors, but there's the big one is really kind of the oops. It's that I deleted my database, and a lot of times it's like, for example, like let's say booking a flight or whatever. I don't want, like, I want it to book a flight, but I don't want it to book a flight that's too expensive, right? So like that's an authorization rule of like, don't book something that's too expensive. But like, how do you control that? Right? You have like, so it's like basically saying like, you know what, I'm going to let you book flights, because like just think about like the policies that we have for like employees. It's the same thing. It's like you're allowed to book flights as an employee. You're allowed to book flights, but like it can't be first class, and it must be within this range and whatever. It's like, how do you express that, and then how do you also enforce that, and then so the direction I think that agents are going is like we just get a lot more utility out of this very unstructured kind of interaction or whatever. And that's, agents are getting better with tools, because now they're just like dynamic, it's like, oh, I can just generate, so there's that one thing, because, sorry, I'm just kind of like ranting here, because I just want to throw out another thing when we look at the code gen, because the problem with the code gen is because you can say like, oh, well, don't authorize the code gen, but the code gen is going to call all these individual tools, and then the users have to authorize these individual tools, but they lose context on what those individual tools are. Like, what the heck is going on? And it's calling this one thing. And what is it? Like, what am I doing? Like, can I authorize this one thing that doesn't make? But then also, like, the whole idea of agents, especially OpenClaw, is like, you have people who are not technical, who are like running around with scissors. Like, how do they authorize that? Because they don't know what it's doing. So there's like so many problems with human in the loop too, with like, how do you even, because like what we're seeing with the coding agents is, the coding agents already do this today, where it's like, oh, do you want to run this command? Yes. What every single developer, what they do is they just turn it off, because it's just annoying, right? So like the more practical approach is like, so you get this like fatigue of like, yes. So it's this thing where it's like, like the I don't know, like I struggle to see that this would effectively work. I mean, technically, if you did enough, but like, if you have to say like, these are the tools, these are the parameters, like, how do you protect against a delete database, right? But you allow them to run delete commands because they can delete, so it's like, now you have to inspect the SQL string. Anyways, so I don't know, like that's kind of like my thing, where it's like, I think like this type of policy works, I think, very well for agentic workflows, back-end automation, but kind of as we move to this more, I don't know, like open. Yeah, I think OpenClaw is a good example. But,
yeah. No, I mean, I totally agree. I think that there are people who have a higher risk appetite, and they're gonna rather move fast than care about securing their systems and blocking everything. I think that's going to be a given. So this is something that, I mean, was originally built out to say like, hey, I want to code on my own server, or sorry, on my own laptop, and I want to ensure that like, as I'm building out these agents, I don't want it to ever touch my database at all. Like, it should never call like the delete tool on my system folder at any point in time, right? So how do we build that out so that it goes at scale? Maybe we do something where it is we can have AI call itself to generate policies that protect the agent, where it says, "Hey, I want you to generate, AIP policies that will provide me, the best hardening against malicious activity," right? So that's one thing that I can see. But at the same time, yeah, I mean, I don't want to click yes and allow and allow and allow and allow on everything. But I think that at like a minimal level, having the ability to block tools that or block actions that shouldn't be done, like my agent as it runs should never like I never wanted to touch anything in my like never delete anything. Like,
Yeah.
and if I say like clean up, my finances, right? Maybe it interprets that as like, okay, clean up like every single financial document that he has on his laptop. Um, it's just an extra level of protection where I'm just like, hey, like, don't touch it, don't do it, and then move forward with what you should do. So yeah, I mean, that's a good question. How do we scale it out? I mean, yeah, whatever the community thinks, I think is the direction that this project is going to go.
So,
Because
oh,
yeah.
sorry.
Oh, sorry. Go ahead.
Oh, because like I honestly like because my current thought, because I've just been thinking about this too much lately, is that I really don't think there's any way to solve this except for like the only way to solve these authorization issues and things like that is to use AI, but specifically AI in the data path is like you actually have to develop models you're going to gain trust with. Like you need to simplify and isolate because it's the same thing you can do. You can do it with humans too. It's like, well, you have 3 different models and you have to require consensus among 3 different personnel. So the like I think the idea of it's like having a concrete data structure that evaluates policy. Like there's an idea of like control plane basis data plane where it's like you can kick up to control plane and do a heavy AI authorization, and maybe it caches that authorization. But like I really only see this is the only solution that I've come up with is like you have to put AI in, and you have to then have natural language policies, which is this is what you're allowed to do. So they're not structured anymore, because like I think that's the whole thing. It's like this is an unstructured problem, and it requires an unstructured solution. To a certain, it's like I think that's the only way I see addressing OpenClaw or whatever.
Yeah. I mean,
we need to wrap. We're gonna go. We've already gone super long. I don't want to have this go.
Okay.
James, this was great. I really appreciate you coming on to talk about this. If people want to get more information, is there GitHub page, web page? Like, where do we find more?
Yeah. Check out. I really want to plug the GitHub, which is let me go to the
back
chart.
in your slides. I put them
there
back.
We go. So this is the organization. It's the Open Agent Identity Protocol. Our docs are on the agentidentityprotocol.io. And most of the standards and specs and the docs are in the Open Agent Identity Protocol /Agent Identity Protocol repository, where you'll also find a lot of issues and discussions that are happening. So yeah, I mean, welcome any question, any feedback, any criticism on this. I think that it started off as like I want to protect my database, so I don't want my AI to ever touch my database at all. And then now it's kind of evolving to be like, okay, like as it gets built out, how do we secure a scale with these agents as it moves around? And if anybody, wants to work on it, hash things out, more than happy to have anybody jump in and yeah, have any discussion.
Awesome.
Yeah.
All right. Well, thank you so much, everyone, for being here. James, thanks for joining us from Paris. Have a great evening in the City Lights, and we will be back again in a week or two. Take care, everyone.
All right. Thanks, everyone.